Hi everyone, my name is Julien Lheureux. I'm the lead tools programmer at Epic, Node.js.
I'm Jean-Sébastien Gay. I'm a technical art director at Epic Games, and I hope everybody got coffee because it's going to be intense.
Oh yeah. All right, so let's get started. This is PCG, Advanced Topics, New Features in 5.5. So we're gonna go over the agenda quickly. We're gonna not really introduce, just do a quick overview on some advanced topics we're gonna talk about today and show a lot of the features in 5.5. And there's gonna be a very long live demo. So let's get started. It's gonna be intense. So first off, attributes. Most of you that are familiar with PCG would know already what attributes are, but something that we're gonna showcase a lot today is using not scalar types and stuff like this, but really a lot of references to objects and data tables and a lot more. And that could be a lot more things as well. It could be graphs, settings, and so on. Something else we're gonna use are tags on actors that through the PCG data asset workflow, especially when we export level instances on top of two PCG data assets. Finally, about attributes, we're going to talk about match and set, which is basically just a kind of a cross-reference. So you can find a line inside of the data table, assign it to a point or an attribute as well. And yeah, because I forgot, this is building on top of talks from Aaron Langmead and Chris Murphy from this year's Unreal Fest in Prague. So if you haven't seen those, you should go back. They're pretty good talks. Okay, next. All right, multi-data. Well, something that's maybe less obvious in PCG is that a lot of the nodes are meant to be multi-data, and we'll do parallel processing when we can, or eventually more and more as we go along, we'll try to do that in parallel. And we've added a couple nodes to support this kind of workflow easier, and so that removes the need for some subgraphs sometimes or some loops. That being said, loops are super useful. You basically break down your data and what you want to do, so you can do similar work on different data. Finally, recursion, we're not going to show today, but we're going to talk a bit because it would be a bit too long. However, we're going to showcase a lot of control flow stuff, which basically allows you to do static or dynamic control flow in your graphs. And yeah, that's it for that part. User parameters. Easy enough. These are things you can specify directly at the component level for users or inside of graphs as well, when you call subgraphs. They don't need to be scalar values either. It's very easy to pass in data tables. If you have data from designers, you can have graphs, you can have a lot of things, and that's extremely useful as well. Finally, runtime IGen is something we've introduced in 5.4, and I'll just do a quick recap here. Basically, it allows you to generate different things at different scales. So basically, you can pre-compute things at a very large distance and maybe just create the visuals when you're up close or just the physics, so you can have something that's efficient at runtime. All right, enough of that, because we're going to go through all of these. So the first thing we're going to talk about today is the shape grammar nodes we've added in 5.5. And we're gonna give you an example of the subdivide spline here. Basically, these are just breaking down splines or segments according to a list of module, and you can do fences, buildings, and a lot of stuff with that. All right, Jess, let's go to the editor. All right.
Okay. So I'm gonna jump in the editor, and we're gonna stay there for a while.
Yeah.
Okay, here we go. So today, we're not gonna do a forest for once. We're going to the final frontier, space. Okay, so let me jump here. We're going to work with grammar, and we're going to show you the grammar stuff. And to work with grammar, you actually need to have modules. Usually it's a single mesh, but in our case, it's going to be multiple meshes. I'm just going to jump here to the kit builder, where we have our asset zoo. And we were able to leverage the Talisman demo from GDC this year, content, to build a space station. So that's what we're going to do today. From all of these modules here that you can see, these are all level instances. We're going to extract some properties that we baked into a blueprint component. And instead of making our own data table, we're actually going to use PCG this time around. So on each of these individual modules level instances, there's a blueprint component called module info. And then there's a bunch of variables here. It's going to be basically the structure of my data table. There's a name, a symbol, a level, a size, and whatever. But most importantly, there's a PCG data asset, which contains the point cloud of all of the visuals within each of these modules. Okay, so far so good.
Yep.
Let me bring up some debug here and open up a graph. PCG component, graph, it's on the other side. Okay, here we go. It's extremely simple. We're getting the level instances within the volume, but we're actually not just getting the level instance actors. We're also getting the component by class, which is new in 5.5. And as you can see here, we're getting the module info.
We can also get components by tabs now, so a lot easier to filter. In this case, we're also getting just the component references, because there's no data assigned to it. Yeah.
And once we have those references, we don't have the properties yet. So we're getting a get property from object path, which is going to extract all of the properties that were set on each of these modules that I've just showed in the viewport there. And these are going to be multi-data. And that's what we mean when we work in parallel. Like we can work with multiple data in parallel here flowing through the graph. And to get that table, we're just merging those attributes together. So now I have my data table at the bottom. Yeah. And there's a symbol for each of these modules that we're going to use for the grammar. Now, I'm doing some branch logic here to export to an asset only when I want to. And I use a save PCG data asset, which is also new in 5.5, that allows you to save any PCG data that is flowing in the graph to an asset. So, quite simple.
And quite useful as well to build some small tools.
Yes.
Yeah.
Okay, just going to click on export here. It brings up the dialog, and yeah, voila, we have a table. Okay, from that table, we want to build our space station. So let me jump to an actor here that was prepared for the demonstration. It has a spline and a PCG component and a grammar graph here, but also a graph parameter that is already overridden in this case. Probably small on the screen.
It's the same, yeah.
But it's going to be important for the later on in the demo.
All right.
We're going to do some fill the blank here for a second because we want to show you how easy it is to work with grammar. But then we're going to enable a few things and show you debug stuff to explain the new nodes.
Yep. All right, so let's get started. First thing we're going to do is loading the module table we just created. So load PCG asset, yeah. Cord. Oops. It's cord word, no? All right.
No, it's not.
That's a live demo for you.
Oh, great.
Okay, maybe you can export it.
Unexpected. We're sorry about that.
Yeah, maybe we could resave. It's kind of weird. You couldn't find it, but whatever. Right, we just dragged it from the content browser. All right, so it does the same thing, loads the thing. Now we're gonna get the spline from the actor itself, so just get spline data. And then we're gonna retrieve the grammar parameter we've added. And we're just gonna add that as an attribute on the spline. That's also something new in 5.5, but basically just allows you simple attributes on splines at one level. We're gonna call it grammar. And then we're gonna use the subdivide spline. So pretty simple. There's a few things we're gonna set up here. First, because the spline has it could be bigger than the grammar we're trying to do, we're gonna accept incomplete subdivisions. And then we're gonna say, we're gonna provide the modules instead of hard coding them in the node directly from what we've loaded. And then we're gonna drive the grammar from the grammar attribute. And finally, we're gonna forward data from the module info also on the output data. In this case, we especially need the PCG data asset because that's what we're gonna spawn.
Okay, so I'm going to enable debug here.
Yep.
And generate once. Put that on the side of the screen. There we go. Okay, so already we have a spline segment that has been subdivided into 4 pieces, end A and end B at the very end, and then some straight modules in the middle. And that's coming from the grammar attribute here. So I had end A, straight star, and end B. Straight star the stars mean that it's going to try to repeat it as long as there's space.
Yeah. All right. So let's go and spawn meshes now. So as simple as we've done it so far, modules are like all in the same package. So we want to extract basically the meshes we want to spawn. So we're going to partition in the PCG data asset.
There.
So, yeah. Hopefully that works. All right, and then we're going to load those. So that's something we've right, so we need to get the attribute first. So basically we're going to extract the attribute from the first entry of each one. So the partition is basically just separating all the inputs into different buckets by value. In this case, we want to extract the PCG data asset from the first point out of every of the partitions. And that's going to drive the load PCG data asset from the attribute. So that's something new as well in load PCG data asset now. You have the option to load from input. So it'll take multi-inputs and attribute sets with multiple lines as well. And that allows you to load multiple things at once. It's also doing async loading by default, but that's not new. From there, we were able to get the points, and we're going to match them to the modules we already add. So in this case, we've added a new option in the copy points as well. Instead of doing a Cartesian product from the source to the target, so every source to every target, we allow doing copies one source to one target. So like this removes the need for additional loops and stuff like this. So it's very easy. Now we've already exported, like basically at that point, we'll have all the meshes at the right places, and we can spawn them.
Yeah. Please ignore the attribute filter here and the add attribute. We're going to talk about that in a sec. But it's just flowing into a static mesh spawner in the end.
By attribute. Yeah.
I'll disable the bug here. We don't need that anymore. And hopefully this will spawn for space station or space station corridor in this case.
Yeah.
Okay. If I drop here and go inside of it, here we go. So as you can see, it's the Talisman demo content. And we have an end and 2 straights because there was enough space for 2 straights and another end at the very end.
Yeah.
Okay, so what can we do with this? Because right now it's kind of small and we can extend it, right? Because it's hooked on a spline. I can just move that around as much as I want and I get new modules from that grammar. But I like to have something a little bit more complex than repeating the straights.
Yeah, it's a bit boring at the moment, so yeah.
We have a complete syntax that allows you to do different things. You can force a module to spawn, but you can also use stochastic random choice here.
Yeah.
And I'm going to put in between curly brackets the straight, door left, door right, and door double, and I'm going to close the curly brackets, but I'll keep the star. So I want to repeat the stochastic choice as long as there's space there for it. And here we go. So we have a space station that now has a bunch of different modules that were randomly selected. Door left and door right, so double doors, door left, a straight, door right only, and so on.
You can also have weights and everything. We'll show a quick slide on the syntax of the grammar. It's pretty basic stuff. Very similar to what we had shown in the Matrix Awakens demo. So nothing really surprising there.
And since we're just segmenting the spline here, I can just like bend it over and go inside of it. Yeah. And here we go. Like we have our space station corridor is still working. Obviously, if you're making 90 degrees angles, you'll have to manage corners properly. There's some work there to do, of course.
Yeah.
But in this case, it kind of works.
So in this case, the modules, we're going to place both ends of the module on the spline itself. So it looks a lot better in this case. Yeah.
Okay. Let's go back to something that I can manage for the rest of the demo. So I'll just put back a straight And I'll keep, let's say, door left, remove the star, and here we go. Shorten the spline. Okay. And do you want to touch on the syntax first?
Right, yeah. So let's go super quickly to the syntax here. So basically you can do sequences with square brackets. You could do stochastic choices with weights, with the column specifier. You can do priority choices, so you're going to try to place the first thing first, and then if it doesn't fit, the second one, and so on. You can have repetitions, either with the star or the plus, and yeah, I mean, that's basically it.
It's available on the roadmap, and it's going to be available in the documentation.
The public roadmap, yeah. So you don't need to take pictures of this.
Don't worry. Okay, let's go inside and we'll do some more from here.
Yeah, because it's a bit bare at the moment. I think we can do a bit more, it doesn't look lived in enough, for sure.
Okay. So the next thing we wanted to do, because, well, we have doors, but there's really nothing behind those doors. We wanted to extend the space station.
Yeah, especially because the left doors, they go into space, which might be slightly dangerous, right?
And if you watch Chris Murphy's talk, he's demoing the PCG data asset workflow, and we've, in this case, pre-placed position or actors, basically, with a specific actor tag. It's an actor and a value. In this case, we have doors, and we're going to load copy point on these specific points and spawn the static mesh once more. So let me enable that right here. It's a bit magic, but
you can remove the tripods, right?
Yeah, you're right. So I can filter them out, so they're not spawned in the scene, but they're still available. They're in the point data, and I can do whatever I want with it. So if I just go inside, okay.
Too fast.
Yeah. If I go inside this room, well, we have side rooms now in our space station, and obviously you can make more complex decision here. You could have a recursive graph in this case, and you could spawn another corridor with another custom grammar and have start to build up a really, really big space station.
But that would be a bit long for the demo, so we decided to keep it short.
Okay. I'm going to enable next a bunch of nodes. Don't worry. Nothing is going to happen. And it's desired.
And yeah, we're going to turn on physics as well.
Yes.
So we're going to need it.
In the static mesh template descriptor, you can enable collisions. By default, they're off right now.
Yeah.
So I'm going to enable collisions here, because what we want to show next is a few new nodes that are going to use Raycast. We're in space. We don't have a landscape. We're not doing a forest. So we want to work with the collisions here. The first thing we do is that we get the same exact spline as the corridor. Then we resample that spline at every meter. Then we're going to use a new node, which is called World Raycast, to raycast against the environment. Let me show you how it looks. Here we go.
So, yeah.
The points here in the sphere is coming from the new node, which is called Create Point Sphere, and they're going to be sent as the origins of a raycast. And yes, obviously, from there, we're raycasting against the environment, and we're getting the whole of the ship.
Yeah, so maybe I can talk a bit more about the word raycast here. So basically, yeah, as Jay said, you can specify start points, directions, or endpoints, sorry. And there's a lot more things we've added to it as well. There's more filtering options and a lot of more data you can get out from it. And all of these that we've actually moved also to the world rate if you're already using that, so you'll have a bit more options there. So, yeah.
Okay. So what can we do with this? I think we want to place a little bit more props in the scene. And to place props, we need to identify the floor, and we need to build some sort of distance field, because we don't want to have props in the middle. In our case, we just filtered the points at a given height because we knew it was flat. Once more, you could do more advanced logic here. Yeah. And we're doing a distance check against the remaining points, so the walls, basically. And that gives us a distance field in point data. From there, we can then select based on that distance. So we are going to filter, and we will end up with potential props position. But these props are quite small, and they're also selected using a random choice on top of the range. We have the possibility now to select a fixed amount of points in the point data or a fixed ratio.
Yeah, instead of it being per point kind of a decision.
So how do we go from there? Because these are not actual props. If you look, there's a few examples on the right there. We need to load them again. So we need to load the content just as we did. But to load the content as we did before, we need to identify each of these props on each of these points.
Yeah. So here we're going to use the matching set. Basically, we're going to assign randomly one line from the data table we've just loaded, which is a separate thing Jason prepared, to each point. Now, the matching set, if you don't specify criteria, it's just going to do a random choice. And it could be a random weighted choice as well. But yeah, that's quite enough to be able to just pick from a list. And then from there, we do the same logic, the partition, and then we load everything.
Yeah, it's exactly the same as before. Yeah. So we're like just assigning the props, loading them, and then spawning them. But in this case, we're using the root point here because it represents the volume of the props. Each of these props are made of multiple visual once more.
Yeah, so we're going to do the filtering logic just on the roots.
Yeah. So next up, we don't have props yet, but we saw that there was a lot of points there that should be clusterized a little bit, and they should be placed a little bit more organized together.
Yes, if we cluster them, they're going to look a bit better. So the first thing we're going to do is a collapse points, which basically removes points around the vicinity of other points. So basically at the end, you end up with things that are at least at some amount of distance from each other. And then we're going to use the attract node, which is also new. Basically, that creates a relationship from a source points to target points and some radius and some criteria, so that from there you can actually do interpolation from the source to the target. So you can move them together, like towards the center of a cluster you found.
While Julien was talking, I just enabled the spawning of these props. So they're trying to just using the collapse point and attract together, like they're just trying to gather at a center position.
Yeah.
And yeah,
finally, we've done some pruning, self-pruning, of course.
Yeah, self-pruning is help us remove them from overlapping on each other, and we can set it to different settings. But in this case, we kind of liked this setup here, so we're going to keep that.
Right.
Okay. So I think that's cool. You could probably do better, but we have a corridor, we have some navigation paths still possible, and we have a lot of props. But we can do more, obviously.
Yeah, I don't think it's sci-fi enough, JS.
Yeah, you're right. You're right.
So we're in space, man.
Yeah, we kind of like sci-fi horror, so let's make that happen. A lot of people are asking, and it's been there since the first release. Yep. You can use instance data packer here in the static mesh spawner to write per instance data on all of your instances. In this case, I had already prepared a float here that I'm writing as an attribute. And this will be written to all of the points that are spawning. I'm just gonna change the float value. And turn off the lights. Okay, so everything is now a little bit darker because I'm modifying the base color, the metalness, and the specular and the material directly from that instance data. But nobody can see anymore anything.
Yeah, it's way too dark, Jazz.
Yeah.
That's not gonna work.
Yeah, exactly. So through the same process as we did with the side rooms, as if you remember, we had the tripods here in the scene. We're going to use the filtering again, and we're going to pick up those positions, and we're going to spawn new lights.
Yeah.
Okay. So here we go. Looks a little bit more sci-fi horror-ish, but we can do more stuff still.
Yeah, for sure.
Okay. While we were doing the raycast in the environment and finding the hole, defining the props position, we were also in parallel doing other stuff. One of them is we were actually creating a point cloud volume along that corridor. It's just using a create points grid, and it's instancing it all over the spline. Okay. And from those points, we can actually do some cool stuff. I'm going to enable what I call the all hell breaks loose mode here. And this mode is actually going to send the different sets of points within the same branch of the PCG graph. So once more, we have control flow, we use multi-data. So I don't have to add more branching in my graph. I can just reuse the same stuff that I did. And instead of placing the props on the floor points, we're actually gonna bring them flying.
Right.
So here we go.
That's cool.
I think we got it by something, and then we went into 0G here.
Yeah, but there's something new as well, right? We've added a wire going through the debris here. Sorry. And maybe we can show that a bit more. So basically, it's a new node in 5.5. We've added a pathfinding node. Basically allows you to do pathfinding on a point data set. You specify a search radius, and you can also derive a cost from an attribute or a fitness score, basically. We also support doing raycast between each points. So if, let's say, you have collisions in the middle, maybe you want to stop those points, those paths. In this case, we didn't really need it because the prop placement and everything, we actually removed the points from the point data we were actually pathfinding on, so that wasn't needed. And that also segues in us showing off the spline mesh stuff.
Yes.
I'll show a bit more later, but yeah.
Yeah, we'll show a bit more later about that, but you can see that it's actually a spline mesh here that is created from PCG as well.
Yeah.
And icing on the top, we just use the same all position or all the points that we had, and we're going to spawn using the random choice, a fixed amount of points here to spawn effects all over the place. So it just looks like we've been hit by something and we're going to hell. Okay, so let's leave this place. I think I'm kind of afraid of what's going to happen next.
All right. So let's go to some cargo holds or cargo space.
We want to build a device here. We like Mars, but we'd like to go somewhere else. I think there's a better place in the
solar system.
In the solar system. And to do so, we're going to build a cargo bay where we're going to put our device. I'm once more going to open a graph.
Yeah.
And I'm also going to
show the primitives.
Show some primitives.
So yeah, this is another example of using grammars in this case, except that in this case we're going to start from primitives.
So we're not only working on splines, but we're also working on primitives. We can get them as before, so get primitive data here. There's a tag on these already. And then we're going into a primitive cross-section.
Yeah,
you might want to...
Yeah, basically that tries to find a footprint of the union of all the primitives that's actually passing the data. So it allows you to have placeholders and replace them by something else and everything. So it's pretty cool.
Yeah, you can see here, like I added another primitive and it combined them together and it created a footprint for my cargo bay area.
Yeah.
Once we have that, we're going to assign a grammar once more as an attribute, but this time around it's going to be a vertical grammar.
Yeah. So basically, from the spline, we're going to apply a grammar based on the height that we know of, and we're going to generate basically it's a duplicate cross-section node here. It's just going to duplicate the spline, assign a symbol to each. So in this case, it's going to be, I think, first floor, second floor, third floor, and then any number of top floors. Yeah. Yeah, so maybe we show this now? No, I think not. So, well, I guess you can. Basically, at that point, we've assigned one symbol per spline, but it's not enough, right? We're going to break it down to segments because that's something that we do have. Lights. It's kind of weird, sorry. So yeah, we're going to break down every spline into parts, and then for each level, we're going to assign it a new grammar. So we have the select grammar node here. That's similar to a match and set at that point with an additional criteria. So we can say, okay, if it's the first floor, assign this grammar. But if the length is too small, maybe we just want to have a filler grammar instead. So that's basically what we're doing.
Yeah, and then we're just going through a subdivide segment, which is like subdivide spline. We send it the module info, just like we did in the corridor. One last thing here I want to show is that we have the reverse spline that I can force a clockwise or counterclockwise behavior. So yeah, like we can make buildings. We can make buildings from shapes. But in this case, we had the reversed building from inside.
We want to see from the inside.
Okay.
All right.
I've enabled the visuals here. I'm just going to jump into this cargo space. I'm going to enable a simple floor and ceiling logic. Don't worry about this. It's just placing modules on the spline surface. I don't think we need to cover that now.
So, yeah. So look a bit more cozy for sure.
Yeah, and I'll actually once more go back to a more manageable space. And I will
sci-fi again.
Go to sci-fi because we like it. Okay, here we go. 0.8 once more.
Yep.
And I'll just disable material overrides in this case. There we go. Okay. So now that we have all of these grammar stuff, we want to present something else.
Yeah, so let's go to the slides a sec. So we're going to talk about some interrupts. We've already introduced a bit the spline meshes, and we're going to see some more, but here we're going to showcase new nodes that we've added very recently, basically adding support for geometry nodes in PCG. So we've added some support for dynamic meshes and interop with geometry script. And yeah, there's some other cool stuff we've added to go with this, like some specific PCG things, but also there's a new PCG blueprint class that's just for that purpose, where especially if you're doing just something on one mesh, it's one function to implement, very simple, so no boilerplate to do. It's really cool. All right, so let's go on.
Yeah, let's go back there. Generate once more, so it's initialized. And yes, another graph. Here we go.
This one's, is it bigger, scarier? I don't know.
No, I think it's quite simple.
It's pretty simple, it's true.
Don't worry. Okay, so yes, we're happy to introduce geometry processing within PCG directly. Right, in this case, I'm going to use primitives. Don't worry, I think you can do much better at home than I'm doing right now. But I can get to something quite cool with some primitives. So I'll just enable debug here as I'm stepping through the steps, because we can work in place when we use geometry processing within PCG. The first thing is we get the static mesh and we convert it to a dynamic mesh. So we're working in the dynamic mesh space. And then we have a nice looking sphere. It's been sent through mesh transform. It's been scaled and whatever. But like that's not a device, right? So we want to make something a little bit more complex. The next thing is I'm going to use a cylinder and I'll do different transforms and I'm going to do a Boolean operation between both. So this will give me a ring. And from that ring, I want to make actually 3 rings that is going to surround my device. And once more, I'm just working in space at the right location and I'm just going through the steps. The cool thing is, now that we have this in the PCG graph, we can actually work with PCG points as well, like point data. So I'm going to create a point sphere once more around the circles. It's just going to be a circle here. And I'm going to append a new mesh to every point position. And I will merge it with the rest of the device. So let me just switch to that. And we have our base object. That's cool. It's the start of a device. Now, this is still dynamic meshes, but that's not what we want in the end. What we actually want is to save the dynamic mesh to an asset as a static mesh actor in the end. We can, just like the save PCG data, we can provide a path, provide a name, and we can actually set a bunch of nanite settings, we compute normals, and we can do whatever we want here. And the coolest part is that I can now work non-destructively. I can just disable all of these nodes that are doing the dynamic mesh process. Since I've saved my asset to a static mesh actor, or static mesh asset, sorry, I can then respawn it directly from within PCG within the same graph. So I'll just disable debug here and enable the spawning of that exported mesh. Here we go. So we have a nanite mesh in this case, and we have the beginning of the device. Now, it's not cool enough. I want to have more details. And to do so, I'm just going to build it from PCG as well. So I'm just sticking together a cylinder and a sphere. And then I'm using the create point sphere once more, but on the sphere surface of the center. And I'm spawning instances of that PCG made asset. And since they're all instances, well, I can use WPO in a material and have per instance movement.
Yeah, and that's starting to look like a cool device, right?
It's starting to look a little bit better, I agree.
But it's floating in space. It doesn't really make sense.
Yeah, exactly. So I'm not going to go through all of the other nodes here because it's exactly the same process as I just did. It's just sticking together spheres, booleans, and trying to spawn them in the end. So here we go. We have some sort of shell around the device. And
cooling ends as well.
Yeah, and it's low detail, obviously. It's just a sphere. Okay, so from there, once more, since we're in PCG, we can go back to PCG point data and we can do some more of the stuff. The first thing that we can do is use the mesh sampler and send any dynamic mesh, like nodes here, processing, into the mesh sampler to get points out of it at any step in the graph. So that's quite cool because I can get points over the shell. And from those points, I can just do some PCG attribute stuff.
Yeah, slight magic, right?
I'll enable everything once more. Here we go. And in the end, after finding the inner outer, doing some culling, I can spawn once more the same detail asset that I created from within the graph, from inside and outside of the device.
Yeah. But it's still missing something, and like it looks like a cool device, but it doesn't look like it's powered or something, right?
Yeah, I think we need additional pylons.
Yes.
And we're going to spawn these. Okay, so more pylons. Here we go. To power the device, we want to connect each of these pylons to the outer shell. And to do so, we're using once more the attract node. These attract node will just find the closest point from each pylon
from the source to target
position, source to target. And then I'm once more just doing some attribute operation here to do just change the tangent of the spline that I want to create, because these points will be pair. They will be the point on the sphere and the point on the pylon, and this will create a pair of points.
Yeah.
That I can use to
do some splines.
Do some splines, right? And from these splines, well, we've talked about it already, I can just spawn a spline mesh.
And yeah, what's cool about it is, at least from what Jess told me, it's a lot easier to do this right now in PCG than to do it in Blueprint. It's basically just specifying the mesh and pass it to Spline, and that's it, right?
Yep, I think it's could not be easier right now. It's quite easy. Okay, so let's go back into the device.
Talk about the like. There's a few things that aren't plugged outside, right? Because when you do the attract, if you don't actually find any target in the source radius, you can mark it as well. And from there, we've actually just filtered those and placed a few effects in there. And
yeah, and we also added components or light components on each of the pylons.
Yeah, which is also a new node, right? There's an add component node now, and that returns you a reference to the component, so you can actually set properties directly from PCG or call functions as well, which is super useful.
Yeah. Okay, enough of the device, and let's
use it.
Let's use it. Yeah. Right. Okay, let's position ourselves. I'm going to use the most advanced user interface there is, the detail panel, and have a nice blueprint
button here.
Editor callable function here, and I'll just click on that.
So it's not Mars anymore, for sure.
Yeah.
I would say it looks like Saturn, but it's missing something pretty important, though.
Yeah, I think it's missing the rings.
Yeah.
And we're going to fix that. Okay. We're happy to introduce you today the GPU compute in PCG. And not only PCG GPU compute, but also direct to GPU scene instancing. So we never have to round trip back to CPU when we're spawning assets.
So we're just going to enable runtime agent in the in the editor. So we're going to treat the editor viewport as a source. And yeah, that works.
So we now have rings around Saturn.
Oh, you got to bump. Oh, you already did. Okay. You'll have to bump the speed, though, as this is massive. The planet here is 6,500 kilometers of radius, probably more or less.
It's like the Earth radius, I think.
Yeah, so it's pretty huge.
Okay, let me jump in here and move around. And if I look here, there's a lot of fragments around Saturn.
Yeah, and these are all 9 meshes, all 5 million of them.
Yeah. Yeah, there's about 5 million in this case. And they will all spawn like well under 1 second here. So I think that's quite cool. But we can go inside of it. So let's just jump here.
Yeah.
I'll reduce the speed.
Yeah, we don't want to be sick.
I don't want to make you sick. And I'll just go inside.
So now it's not only the 5 million things, which are like the big rocks here. We've also used Runtime Agent to do additional details up close, and then add also additional details on the rocks.
Yeah.
So
if I move around,
because we wanted more.
Yeah, we can use Runtime Agent and the PCG GPU compute, GPU scene instancing to do so much details. Obviously here, the 5 millions are spawned at the beginning and it's everywhere. But as we move within these rings, we're spawning micro details on each of the individual rocks. There's about 10,000 points on each of the rocks. And there's also some filling, I don't know if you can see on the screen, but there's some filler being spawned as well through the same process. And in total, it's probably 6 million at all time when I move around. And you can see that the frame rate is quite good, thanks to Nanite and the fact that we only compute once when we need it.
Yeah.
Yeah.
You could show the Nanite triangles if you want to. It just looks like a triangle soup at that point, but you get the picture. All right, so let's show the graph, JS.
Sorry,
Interesting.
I'm afraid I can't do that.
Come on.
I'm just kidding. Okay. Let's go into Final Frontier and open up the graph. Okay.
All right. So we've added a custom HLSL node with 3 variants. The point generator, which creates points. The point processor, which allows you to do transformation or reject points, stuff like this. And of course you can have a custom HLSL node where you have nothing set up. But basically, the big difference is that we're going to give you declarations so that you're able to get data from the pins directly. And we've also provided a couple of methods to make it easy to use. And I think the coolest part is the source editor we've added for it as well. Yeah,
I just went through the window node source editor here, and you get a HLSL code editor here with some highlighting for you. I'm not going to go through the code here. It's just making points from the GPU. It's copying them using the native copy point, but this time around, it's executing on GPU here. So we have added copy point and static mesh spawner, obviously, supporting GPU compute. And all of these together are actually going to be one compute graph running all at once. And it's never going to round trip back to CPU, as I said. But you can, though. You're not forced to stick on GPU. You can pass data from CPU to GPU, and you can send it back to CPU if you need to, for obvious reasons like collisions. Okay. And it's actually what we're doing in this case. We spawned the 5 million fragments around Saturn, but then we're going back into this merge node, which pushes back the data, just the points, through the CPU. And then we're running through the hierarchical generation as we move around in a fixed grid size here. We're calling the points for each of the grid's bounds, and then we're going back to GPU. We're pushing the micro detail assemblies. We're copying them on each of the rocks points at the right position, rotation, and scale using the GPU compute again. And we're actually spawning through the same process here as well on GPU.
Yeah, and one thing to know is that the static mesh spawner here, it works with weighted choices, but also by attribute, which makes it extremely useful. And then you can show off the grid as well.
Yeah, I've enabled debug here to show you where we're actually generating. Where we're actually generating the micro details and the filler fragments around us. So everything that is within those bounds will be generated on GPU as we move using the runtime hierarchical generation. Everything outside is the global, but there's no micro details. And there we go. And this can be quite scalable because you can have multiple grid levels. You can scale them. We added a multiplier because of the scale. we were working in.
It allows you to shift the grid to bigger sizes. So like you can have, I think the bigger grid size you can have at the end is 2,000 kilometers, which was good enough for us in this case. But yeah, it looks good from inside of it. It looks good from outside of it.
Yeah, and it looks good from quite far as well.
All right.
So here we go.
Okay, we can go back to the slide for a sec, but it's going to be a short one. Yeah, so we've shown custom HLSL nodes. We are starting working in GPU nodes, right? It's really like the first drop. You could do your own nodes. It's not, I wouldn't say it's easy, but it's doable for sure. And then we've shown GPU instancing. It comes with some limitations, like ray tracing doesn't work, for example, because it needs some CPU data. In this case, since we never went back to CPU data, the CPU, we don't have it. And yeah, we've shown some more, which we're not going to go through again, but all of this is on the public roadmap, I think.
Yeah, it is. You can read all of the details for all of the new features that we didn't cover today. Well, we did cover some of these, but everything is there. So please have a look at the public roadmap.
Yeah, and finally, while we've been working on the demo for like a couple of weeks, like 4 weeks, I don't know.
2 weeks,
let's say 2-3 weeks, right? It's been just us showcasing the work of the team that have done a stellar job again. So yeah, thanks to the team, and then thank you guys for attending.